In this video, we'll analyze the replacement of inlet guide vanes on a fan with a variable speed drive. I'll move to the energy screen. I'll select from the energy end use drop-down, fans. Only one choice here. I begin, as in many cases, with the specification of the motor type. To begin with, we'll probably be working with a standard efficiency motor, and in this case, we'll specify a motor horsepower of 20 horsepower, small return fan. REDScreen from its database pulls the base case full load efficiency, and I have to specify the load factor or the loading on that motor. From a current measurement, I've determined that 75%, and I proceed to specify aspects of the fan. I need to specify the type of fan I have here, and this you're going to be able to determine either by looking at the fan or from shop drawings. We'll go with a forward curve fan and efficiency of approximately 65%. Now, in this situation, we're not dealing with constant flow in the base case. We're in fact dealing with variable flow, but we're achieving the variable flow with a inlet guide vane, which is still a relatively efficient way to do it. Now, because the system is oversized for its application, that inlet guide vane is throttling that system down quite a bit, and so we're going to go with low flow range, which is heavily throttled or heavily restricted. The system is operating 24 hours a day in an operations center, so we'll specify that, and we have our base case consumption of energy of 43,261 kilowatt hours. We're now ready to analyze the proposed case, so we'll begin by copying base to proposed. Now, if we're replacing this motor with a motor and a variable speed drive, likely we'll be using a premium efficiency motor, which is also inverter or drive duty rated. At this point, REDScreen is compensated for the increased efficiency of the premium efficiency motor. We can accept the fact that it's a forward curve fan. We're not going to change the fan. We're going to use the same efficiency as the base case because we really don't have information at this point to suggest otherwise. We have variable flow. It's in the low flow range, meaning that we're highly throttling or restricting this fan. But in this case, we're not actually restricting it. We're using speed control. So we're going to select variable speed as the flow control type. And at this point, we have our proposed case calculation complete, a 28% reduction. And for a cost of $6,000 to complete this retrofit, right, we move to our include screen and we see this project has a simple payback of 5 years.